Hi everyone, we are proud to present our article called The Impact of Forgetting on Operators' Learning Coefficients Caused by Interruptions in Production, whose authors are José Ângelo, Edson, Arthur, and João Paulo. So firstly, one of the challenges of the production programmers nowadays is to predict through more precise techniques the time required to complete a manufacturing lot within the time desired by the client, having as criterion the learning coefficient of the operators. Several mathematical and statistical models have been developed, but there are not many studies that discuss the forgetting caused by voluntary stops or not in production and their impact on relearning. In this study, the model used was right potential model, which suggests that when the cumulative number of units produced doubles, the unit's production time decreases by a constant percentage. And here is the model of Wright. And other researchers have also addressed in their research the impact of forgetfulness. However, it is not the focus of this research to develop each of these studies. For this research, the algorithm developed by Lindecke was applied, which can be described by the equation. And here is the Lindecke model, and the model described by ourselves. And the objective of this study is to investigate the effect of learning and forgetting in the scheduling of production batch in the backward sewing sector of a furniture industry for the development of model that incorporates the theory of learning and forgetting. This allows measuring and comparing the performance of experienced and temporary workers before and after planned interruptions in production and measuring the impact of forgetting on the learning rates of these workers on performance and consequent production after these interruptions, thus providing a more assertive technique to production programmers in the programming of manufacturing lots with a higher probability of meeting the deadlines demanded by customers. This experiment was conducted in three phases. First, production data and process times were collected for a period of 113 days, of which 78 days were worked. The data were obtained in the rear assembly sector of chairs of a furniture industry located in the state of Paraná, Brazil, composed of 5 employees, 2 experienced and 3 newly hired. The next phase of the development was to define the rate of learning, forgetting, and relearning of the research subjects, considering the interruptions of production on weekends and vacations already scheduled. In the third phase, the data of all subjects were analyzed and the comparisons were made to ratify the developed model. In this research, a model is proposed based off the working days of the week, regardless of production stops or not, differing from Wright's model that considers consecutive days. This research also offers a method that aims to unite learning and forgetting, thus estimating the performance of operators after interruptions. So here we call P as the vector of worker performance in the previous day's interruptions. For the days not worked, the component of the corresponding P vector is equal to 0 because there was no production. Figure 1 illustrates the graph of performance P through each catalog day. For learning estimation, considering the performances of an employee only in the standard week, that is, weeks in which are worked 5 days and in 2 days there is no production. Therefore, from Monday to Friday and in pauses between Saturday and Sunday. And figure 2 displays the same performances as figure 1 before the holiday stop, but only standard weeks are considered in it, taking into account the discarded weeks in the spacing of the data. These models estimate the learning curve on each day of a standard week. With these, the performance of a worker can be estimated in periods in which there are no major interruptions in production. Figure 3 shows the steps of the regressions next to the data, and Figure 4 shows how the employee's performance would be if he had not gone on vacation from the 116th day. The next step of the method is to calculate forgetting, using as reference the available data prior to the vacation period for each amount of days left. Therefore, it's necessary to calculate an arithmetic mean of the values for each number of days. In the next section, this data will be presented for the problem. For now, we will denote these values by F1, F2, and F3. With the data set of forgetting, we find the coefficients of the regression model proposed for the calculation of forgetfulness. Continuing, Figure 5 shows the adjustment applied to the sample data and evaluated the number of days left due to vacation, the estimated forgetting. In addition, this figure shows the forgetting that was calculated only with the data prior to the vacation period, assuming that the later data are unknown. Calculated the coefficients A and B for the worker analyzed, it is estimated the forgetting in the vacation period applying the previous equation. The definition of forgetting equation is then used again to estimate y, c, and plus 1, that is, the performance after the return of the holidays. Having calculated the approximation for y, c, and plus 1, the same models calculated to the linear regression model I applied with the same angular coefficients a and the linear coefficients b of the lines are recalculated. This allows you to estimate performance on the days following the holiday interruption, and consequently estimate when a particular item or scheduled batch of product will be completed. Figure 6 shows the y, c, and plus 1 point in the new adjustment. The linear coefficients on the other days of the first week after the holidays were estimated by arithmetic mean based on the difference between the adjustments made in the linear regression model for Monday. For data analysis, for the application of the method in analysis of the data, we first analyze the learning and forgetting of the 5 operators, OP1, 2, 3, 4, and 5, of the work center use the Wright and Lindecke models, as demonstrated in the following steps, taking as an example operator 1, in which was replicated for all operators. For the operator performance, the operator performance was raised as shown in Figure 7 per weekday, data extracted from the survey of the production for time of the days worked by the operators in the analyzed period. It is observed from Figure 8 that during each week learning occurs. However, the impact of forgetting after weekends is observed, which every Monday presents a longer time in minutes compared to the Friday of the week before the weekend. The forgetting factors of all interruptions occur in the period, weekends, and holidays of all operators of the work center were calculated applying the Lindecke model. In this stage, the arithmetic mean of the factors of forgetting of the days still was calculated according to the occurrence of interruption in the periods 1 day, 2 days, and 3 days of all operators, having an occurrence of 1 day, 14 occurrences of 2 days, and 2 occurrences of 3 days. To calculate the return time in minutes, the regression model for forgetting was previously applied for each day of stop value verified, 1 day, 2 days, and 3 days. With the set of forgetting data collected by the means of the forgetting factors presented in previous table and the values found by the regression model, it was possible to project a line from these points and obtain the equation of it. For each operator, the points considered of each x and y axis to obtain the line equation are shown below. For the average forgetting factors, with operator 1 as an example, 0.61095 was found for inclination and 0.373078 for interception, shown in figure 7. The table below shows the slope and interception values found for each work center operator. So for operator 1, 2, 3, 4, and 5 again. With the slope and interception of the line, the variables are replaced again in the equation to find the forgetting index for the 16 days of study. For operator 1, the calculation follows as follows. The table below shows the indexes found for each operator. Again, for all the operators in the industry. To identify the return time in minutes, we use the Link-Decker equation, which uses the value of the Monday of the last working week before the stop, the last day worked before the interruption, and the projected forgetting index. The performances on the other days of the first week after the holiday were estimated by arithmetic mean based on the difference between the adjustments made in the linear regression equation. And here are the estimated performance for the other operators. In this study, a model was developed to calculate the impact of learning and forgetting caused by possible stops in the production of the backrest sewing sector of the furniture industry. The study developed in this research allowed the development of a new model presented in the methodology that incorporated the theories of learning and forgetting, as well as their effectiveness and accuracy in measuring the production times of each operator involved in the process, allowing, in the light of the theories of learning and forgetting curve, a more effective planning of the production of each sector and its respective capacities, aiming to align them with the demands of customers. Thank you everyone for your attention.